you, but what we'll start now. Let me share screen multiple participants and we'll go ahead. The last time what we were doing was we're talking about intersection using Venn diagrams. I remember example 1.11 we were doing. After that we went into intersection. So what is intersection? Somebody can read?
The intersection of two sets A and B is the set of all elements common to both A and B. It is denoted by A intersection B and read as A intersection B.
Okay. In symbol?
In symbol, A intersection B is equal to X is to X belongs to A and X belongs to B.
No, actually, don't read it as X is to X. Is that how they taught you to read? X is X such that X is an element of A and X is an element of B. Like that, it makes sense. X, the set A intersection B is made up of elements called X. Okay, that is the meaning. Such that X is an element of A and X is an element of B. It is both and. So this and is very important. Both and is intersection. Either or is union. Never forget that. Okay. Either or means union. Either it is an element of A or it is an element of B, then it is a union. But if it is element of A as well as or both element of A and element of B, then it is an intersection. Okay. Can you continue to read?
Yes, uncle. Intersection of two sets can be represented by a Venn diagram as given below.
Right hand side Venn diagram. So that common area only is intersection. Right. So this common area. So if 3 is common to both 1, 2, 3, 4, 5, then 3 is an element which is found in both 1, 2, 3. This is set A and set B is equal to 3, 4, 5. And 3 is common to both the sets. Therefore, A intersection B is okay. So mathematically, you write it as A intersection B equal to 3. Venn diagram wise, you draw it like that. Okay. So if A is equal to 1, 2, 6, B is equal to 2, 3, 4, then A intersection B is, which one is common? 2 is common. So A intersection B is 2. Okay. That's how you find out the intersection. Okay. Let us go on. Okay. Example 1.12. Sandhya, can you read example 1.12?
Yes, uncle. Let A is equal to X such that X is an even natural number and 1 greater than X less than or equal to 12, and B is equal to X such that X is a multiple of 3, X belongs to N, and
We
X
did this.
are equal to 12. B two sets, find A intersection B.
X is a multiple of 3, X is a natural number, X is, this is set B, this is set A. 4, 5, 6, 7, 8, 9. Okay, let us extend it 10, 11, 12. Okay. So we have 9, 6, and 3, and 12. So find A intersection B is a multiple of 3, even natural number. Oh, it is even natural number. 2, 4, 6, 8, 10, 12. Then this one is 3, 6, 9, 12. And common element is 12 and 6. So A intersection B is 6, 12. Very good. Okay. Now you understand example 1.3. If A is 2, 3 and C is null set, What is A intersection C?
Null set.
Null set. There's no common element because the element must be okay. It must be found both in A and in what is a set builder notation telling? It is such that X is an element of A and X is an element of B. So 2 is an element of A, it is not element of B. 3 is an element of A, it's not element of B. So like that only it goes. So none of the elements are in common. So A intersection null set will be null set. Correct? The second law is true here. A intersection A will be A because every element in A will be present in every element in A. Okay. So that is easy to understand. A is equal to 1, 2 and again A is equal to 1, 2. Okay, so every element in A will be present in A. So A intersection A will be A. Okay. At the same time, null set means nothing is there. Nothing in here is present here. So A intersection null set will be null set. So that also you understand. A intersection union is equal to A. Okay. Look at the diagram like this. This is universal set. This is set A. Okay. Now in A we have 1, 2. In here you have 3, 4, 5. Okay. Now A intersection union. Okay. What are the elements common to A intersection union? Union is 1, 2, 3, 4, 5. A is 1, 2 only. So the common elements are 2 and 1 only. So this is the same as saying that A intersection union is equal to A. Okay, that's all. Actually, A union will be what? Will be union because it is found either in A or in union. That is a definition for union operation. For intersection, it must be found in both A and in union. In both A and in union, only these two are found. Okay, so that is one more thing. Then A intersection B is a subset of A. A intersection B. Let us take A and let us take B. And this is A intersection B. This part is A intersection B. This is A. This is B. This is A intersection B. It will be a subset of A. What is A? A is this whole thing. This whole thing is A. So A intersection B is the smaller thing. A intersection B. It will always be a subset of A. Okay. Same way A intersection B will also be a subset of B. Because what is B? B is this whole thing. So B is this whole thing. Okay. So the small part of B. This is a small part of B. So A intersection B is a subset of B also. Okay. So like that. Then A intersection B is equal to B intersection A. That is commutative. Okay. Either this thing, no. A intersection B, you can call A and B, and same as B intersection A. Either way, this is the same thing. You call it A intersection B or you call it B intersection A. It's all the same. Okay, so it is commutative. Now we finished there, I think. Okay. Let us go for the next statement. Something more we should learn now. Okay. B is a subset of A. How do you denote it in a Venn diagram? This way only. Huh? B is a subset of A. That means this is B. Okay, this is B. And this is A. So this B is within A. So it's a subset of A. That's how you should show. So whenever they are asking you to say B is a proper subset of A, how do you show? You put A outside, you put B inside. That's all, matter over. B is a proper subset of A. Okay. then the union and intersection of A and B are represented in Venn diagram as follows. Shaded region is A union B. A union B then is equal to A because B is completely within A. So A union B will be A only. Okay, let us put it like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, A union B will be what? 1, 2, 3, 4, or like that up to 10. That will be A union B. But what is that? That is only A because everything is inside A, right? Because B is only 9, 10. Rest of it 1, 2, 3, 4, 5, 6, 7, 8 is not inside B, but it is inside A only. So what is A? A is 1, 2, 3, 4 like that up to 10. That is A. So you see A union B and A are the same thing. So A union B is A. Okay. Now A intersection B. A intersection B will be B. This area only is A intersection B. Okay. So A intersection B for the same numbers will be 9, 10. All will be outside. 8, 2, 3, 4, 5, 6, 7, 8. Everything will be outside. Only 9 and 10 are inside. So A intersection B will be only that which is common. What is common? Only this region is common to both. Okay. Only this region. So A intersection B will be 9 and so A union B will be A intersection B will be B. Then now take this one more thing. Suppose A union B is equal to A intersection B in some kind of sets. There are two sets A and B. Then A union B is equal to A intersection B. That is possible only under one case. It is possible only under one case. Okay. Okay, 1, 2, 3, 4, 5. A is equal to 1, 2, 3, 4, 5. Okay. Because what is all coming inside A. Is all coming inside A. What is all inside A? 1, 2, 3, 4, 5. Now, this is all coming inside B. B is again 1, 2, 3, 4, 5. So A is equal to B here. Okay. So A union B will be equal to A intersection B only in the case where A equal to B. In no other condition can A union B equal to A intersection. Okay. Now there are some laws they are stating. These are very confusing laws. I am somehow thinking we should exclude them. But let us see how to explain this law to you. Okay. First, let me explain law B and law C. Law B and law C first let us explain. Then they are the simplest to explain. Okay. N of A union B. Let us say, now take two disjoint sets. This is A, this is B. Okay. N of A union B. The number of elements inside this is P. Let us say P is equal to 3 and Q is equal to 2. Okay. 1, 2, 3 is here. A, B is here. Okay. In that case, A union B is equal to what? 1, 2, 3, A, comma B. But what is N of, what is the cardinality of A union B? How many are there? 1, 2, 3, 4, 5. So N of A union B is equal to 5. Okay. So P plus Q, 3 plus 2. P plus Q is equal to 3 plus 2. That is equal to 5. Okay. So the maximum of N of A union B is equal to P plus Q. That is what he is telling. Huh? So this is one law. N of A is equal to B, N of B equal to Q. Then maximum that comes from N of A union B can be 3 plus 2. If they are not disjoint sets, let us draw something else. 1, 2, 3, A, B. Okay. A union B is what then? 1, 2, 3, A, comma B. Okay, is there. The maximum of n of A union B. N of A union B is again equal to 5. Okay. But in this case, what is A? A is equal to 1, 2, 3, A, and B is equal to 3, comma A, comma B. Okay. 1, 2, 3, A. So n of A is equal to 4, that is equal to P, and n of B is equal to 3, that is equal to Q. That's P plus Q is equal to P plus Q is equal to 7. Okay. So maximum n of A union B becomes 7 in that case. Okay. So that is not possible. So these laws are very confusing laws. I will advise you, if any question come on these laws, you ignore them because your book is not telling you what those laws are. And I am not sure these laws are correct. Okay. Let us forget those laws, very confusing laws, and move on. If any question comes relating to the laws, you forget them. Don't attempt that question. Okay. Let us do the two things. Difference of two sets. Difference means minusing, subtracting. Okay. A minus B or B minus A only is called difference of two sets. Okay. Let A and B be two sets. The difference of set A and B is the set of all the elements which are in A but not in B. So set builder notation is very important. A minus B, difference of two sets means A minus B. X, all the elements in A minus B are such that X is an element of A, but X is not an element of B. So X is found in A. At the same time, because it is and, both and, X should not be found in B. B minus A is what? Y is an element of B minus A such that Y is an element of B, at the same time Y is not an element of A. Okay. Let us see in Venn diagram terms what this means. Okay. Now A is 1, 2, 3, 4. B is 4, 5, 6, 7. Okay. Take these two sets. Now apply the set builder notation. X is an element of A, but X is not an element of B. Okay. X is an element of A, but X is also an element of B. So you have to crash it out. The other one, X is an element of A, 1 is an element of A, but it is not element of B. So you can retain it. 2 is an element of A, but it is not an element of B. So you can retain it. 3 is an element of A, not an element of B. You can retain it. So A minus B is actually equal to 1, 2, and 3. All right. This part alone. 1, 2, and 3. Same way B minus A. Let us take B minus A. Let us take same two set of drawings. I'm sorry. Let us take B minus A. Same two sets. Okay. A is equal to 1, 2, 3, 4. B is equal to 4, 5, 6, 7. Now you have to see Y such that Y is an element of B. Okay. Y is an element of B, but it is not an element of A. No, it is in A. So you'll have to cancel it off. Y is an element of B and is not an element of A. Yes, 5 is like that. 6 element of B but not an element of A. Correct, 6 also. 7 element of B but it's not an element of A. Okay, so B minus A is equal to 5, 6, 7. Okay, this area 5, 6, 7. So that is one thing. Okay. Venn diagram for set difference. Now sometimes A intersection B may not be there. They might be disjoint sets, in which case A minus B will be A. In this case, A minus B is everything in A will be in A minus B, because there is nothing common that A has with B. Okay, there is no intersection. So A minus B will be A in this case. Let us do an example and see. We will get some more clarity. You're understanding, guys? New properties we are seeing. Example 1.14 we'll do. A is equal to minus 3 to 1 and 4. Okay. B is equal to 1 to 0, 1, 2 and 4. Find A minus B. Can you do this sum? I will put it on the board and you can do this sum. Anything is there or something is there? This is all 11th standard maths, huh? Operations research. You will enjoy it when you come there. You will become a manager and you will use these tools in order to do your management work. How much production, how many units to produce, how much to stock up, all that you can do. So meanwhile, let us do example. Example 1.14. Okay. A is equal to minus 3, minus 2, 1, comma 4. B is equal to 0, 1, 2, 4. Okay, what is A minus B? It must be an element of A. It must not be an element of B. Okay. Puna, can you do A minus B? You can tell and do. It's shared.
Yes, uncle. A minus B is
It must be element in A, but it must not be in B. Those elements you write down. For each one you tell and do.
For A minus B, minus 3, minus 2, uncle.
Okay. What about 1 and 4?
1 and 4 is B minus A.
No, 1 and 4 is found inside. It is there.
I'm sorry,
It's also there. So these two are already part of B. The definition of A minus B is it should not be an element of B. Okay, correct. Okay, Sandhya, can you do B minus A? You must go from B, each element in B. Okay, fine. Let's still use that step. Okay, very good. 0, 2. Very good. Okay, you can erase it. Okay. Symmetric difference of sets, something else there. Before that, you are having some rules. Let us see those rules. A complement is equal to union minus A. That is very important. How You can draw a diagram and you can understand that. It is union. This is A. Okay, this is A. A complement is this part. Okay. So union minus A. Now that you know how to do minus, okay. So suppose say 1, 2, 3, 4, 5 is there. Okay. Now what is A complement? A complement is union. Union is 1, 2, 3, 4, 5. This is union. A is 1, 2, and union minus A is equal to, okay, it must be in A, but it must not be in B. Okay, so it must be in U, is there in U, but it's also there. So no, not this. It's there, 2 is there, it's also there. So not this. 3, 4, and 5, they are there only in union. Okay, union minus A is equal to 5. But union minus A is A complement. Okay, so A complement is equal to 3, 4, 5. So it's correct. Okay, so this area, A complement area, is correct. So that you understand that. Okay, then A minus B is equal to A intersection B dash. Okay, this is also quite complicated. Let us have A and let us have B. Okay, A minus B is this area. Correct. But A intersection B complement. Now what do you have? You take B complement. Okay. What is B complement? Everything other than B is B complement. This is B. Everything other than B is B complement. Okay. This is B complement. And he is telling A intersection B complement. What is A intersection B complement? This only is A. So this one area, which is A intersection B complement. Okay, A intersection B complement. So you find that A minus B is finally equal to A intersection B complement. Because what was A minus B? Initially what we found? This area we said is A minus B. Okay. Now same thing is coming. A intersection B complement is also the same thing. Okay, either way it comes. So A minus B is equal to A intersection B complement. That also you understood. A minus A is null set. Okay. Because in A you have, let us say 1, 2, 3. Then again A you have 1, 2, 3. Now minus that. Okay. Every element in A is present in B. So you'll have to cancel. Every element in A will be present in B. 3 is present in A, it will also be present with. There will be no element in A which is not available in the next set A. Okay. So that will become null set. So A minus A will be null set. A minus null set will be A because every element in A will not be in null set. So all the elements will count. Okay. So that is also you understand. 1, 2, 3. Let us say that is A. Then null set is B. Okay. A is element here. 1 is present in A but not present in B. So A minus B, you can take 1. You can take 2 is present in A but not present in B. So 2 also you can take. 3 is present in A but not present in B. 3 also you can take. So A minus B will be 1, 2, 3, which is equal to A. So A minus null set will be A. Okay. Then A minus B is equal to B minus A only if A is equal to B. Okay. Otherwise, this is not commutative. See, A union B is equal to B union A. This is commutative. Same way, A intersection B is equal to B intersection A. This is also commutative. Both are commutative. But A minus B is equal to B minus A is no, this is not true. Okay. Only in one case it will be true. When? Which case? Only when A is equal to B, A minus B is equal to B minus A. In which case, anyway, it will be a null set. Okay. Let us take an example and see. A minus B equal to B minus A. Let us say A is equal to 5, 6, 7. Let us say B is also equal to 5, 6, 7. Now A equal to B. Yeah. Now A equal to B. In this case, A minus B is what? A minus B is equal to, this is the 5, but it's there. So not this. 6 is also there. So not this. 7 is element of A, but it's also element of B. So not this. So null set you will get. So A minus B is equal to B minus A will be equal to null set in the case of A is equal to B. Okay. Only in that case it will be there. Otherwise, this is not commutative. Set difference is not commutative. Only union is commutative and intersection is commutative. A minus B or difference of sets is not commutative. Okay, that we have done. And now let us go to symmetric difference of sets. What is symmetric difference of sets? Okay, there are two sets A and B. Now the set A minus B union B minus A. First is A minus B. Second one is B minus A. Both are symmetric. You make a union out of them, then it becomes a symmetric difference of sets. Okay. They have a separate symbol for that. Okay. This is a delta. Delta symbol is used for symmetric difference. A delta B. As soon as you write that, you must put, oh, symmetry. Ah, okay. They are symmetrical. That means both ways. Union both ways. Okay. Now let us do an example. You will understand that, no? Very simply. X, set builder notation, you understand? X is an element of A minus B or X is an element of B minus A. Okay. This is not intersection. This is union, right? So either X is an element. Unwritten letter is either X is an element of A or X is an element of B minus A. X is an element of A minus B or X is an element of B minus A. So find the symmetry A delta B, symmetric difference. In order to find out, first you have to find out A minus B. A minus B, 6. First you take 6. 6 is present in B? No. So you take 6 in A minus B. Right. A minus B. 6 is present only in A. So you take A minus B. 7 is present in 8, 10, 12. No. 7 also you can take. 8 is present here and here. So don't take 8. 9, yeah, 9 is not present. Okay, you can take. So of all the elements, 6, 9 and 7 and 9 are A minus B. Very good. Okay, B minus A. B minus A. Okay, now what you have to do? B minus A. 8 is present in B. Is it present in A also? Yes, it is present in A also. So then you cannot take it. 10 is present in B. Is it present in A? No, it is not present in B. So B minus A, you can take 10. Okay. 12. 12 is present in B. Is it present in A? No, it is only present in thing. So you take B minus A is equal to 10, 12. So both is correct. Okay. Now what you have to do? You have to do union. Union of both these sets. Which set? Union of this set and this set. Okay. So 6, 7, 9, 10, 12. Because there is nothing common. 6, 7, 9, 10, 12. Everything will come. Okay. So A delta B will be 6, 7, 9, 10, and 12. Okay. That is what is A delta B or A symmetric difference B. Okay. What is A minus B intersection B minus A? Okay. Now you see this one 6, 7, 9 intersection 10, 12. What is there? Intersection. Anything is there common? It is found both in A, this one and in this one. Nothing is found. So that is equal to null set. This will be equal to null set. Okay. Thinking corner. Anyway, let us not deal with thinking corner and all. It becomes, then things will become very complicated. Okay. Now represent A delta B through a Venn diagram. Okay. Very simple. First step is everything that is in A but that is not in B. This is A minus B. Okay. Then everything that is in B but that is not in A. This is the second one. Then the union of both of these. Okay. So that means this plus this. That's all. That is only A delta B. Okay. This plus this area. Okay. So actually in one way it is like A delta B is equal to A union B minus A intersection B. Okay. If you see this area is A intersection B. This whole thing is A union B. So A union B minus A intersection B will be A delta B. That is what it is there. Okay. This formula, that's why he is telling that A delta B is equal to A union B minus A intersection B. Okay, it's very correct. Then another thing is this is commutative. Only A minus B is not commutative with B minus A, but A delta B is commutative with B delta A. Okay, A and B are the symmetric differences is commutative, but the simple difference only A minus B is equal to B minus A, no, not commutative. But A delta B is equal to B delta A, yes. A symmetric difference with B is equal to B symmetric difference with A. But A minus B with B minus A, no, that is not commutative. This is commutative. Okay, so this is because you see either way is the same thing. This only will come. This only will come, whichever way you take. Okay. Then A symmetric difference A is saying is null set. Okay, let us find that. A symmetric difference A. That means A minus A union A minus A. What is A delta A? A delta A is equal to A minus A union A minus A. Okay. What is A minus A? Null set. What is again A minus A? Null set. Empty set union empty set, what you will get? You will still get null set only. Null set only. So A symmetric difference A is null set is correct. Okay. Then another one. A symmetric difference B is such that X is an element of A union B and X is not an element of A intersection B. That is the same as saying this. Okay. This is in set builder notation. This is in simple notation. Set theory notation. X is an element of A union B and X is not an element of A intersection B. Okay. Let us put this here. X is an element of A union B. 1, 2, 3, 4, 5, 6, 7. Okay. Now, X is an element of A union B, but X is not an element of and. And means both and. The condition must be both and. X is an element of A union B, what? You can say 1, 2, 3, 4, 5, 6, 7. All of these are element of A union B. Okay, but and X is not an element of A intersection B. Which one? This one is an element of A intersection B. So you should take that away. So the final result will be 1, 2, 3, 5, and 7 only. Okay, this is only A delta B. Okay, the same as saying A union B minus A intersection B. Okay. Now you have known all these things. Let us go and start doing some examples and exercises. Then only we will know what we are doing is how much we are enjoying. Okay. From the given Venn diagram, write the elements of A. Okay. Arpana, you do the first one. Wait, I will put it on whiteboard. And then you can do that exercise.
Yes, uncle.
You don't look at your book, otherwise it's a waste.
Yes, uncle. I'll just shade in the parts, uncle.
No, you write the set out like this. First one is asking what is A. Okay, you write out what is A. Okay. A, I, U, E, O, V, C. Okay. Write out what is A, set A.
Okay, uncle.
Very good. Excellent. Okay, that's very good. Okay, Sandhya, now what you should do? You should do B. What is B? Okay. Very good. That's also excellent. Okay. Now, third one we should do. Arpana will do what is A minus B. You can mentally shade and then do the remaining. The Venn diagram, you can mentally shade and you can write the remaining. Or you want to put one more diagram and then shade it and do that also. What is A minus B? It must be an element in A. It must not be an element in B. So from you have written A and B already. From this you can find out. One by one you can go. Is A an element in A and it's not in B? Yes. Like that. One by one, each of these elements you take. X element of X belongs to A and X does not belong to B. That is the condition. Each element you take. X is first A, X is for then I, X is U. Like that you write. You are thinking a lot. All you have to do is take each element, see if it is in A alone and it is not in B. If it is in A alone, you write it.
Shall I do, uncle?
Okay, do. Arpana can do next one.
Sorry, uncle. I think there was some problem. I couldn't hear you properly.
Okay. Let her finish it. You will do the fourth sum.
Okay.
Very good. Yeah. So it is in A alone. It is not in B. Very good. This is also correct. Okay. Let us now delete something or let us shrink this up. Now on the right side, let us do the fourth sum. Fourth one is B minus A. Very good. Okay, Sandhya, you should do the fifth sum, which is A complement. Let us assume that there is something on top of this also. This is universal set. What is A complement? You can draw the Venn diagram. Can you draw the Venn diagram? And shade the A complement area. Oh, they are given something else. Universal set is, there is D, there is G, and this is the universal set. Okay. Now you do A complement. Sorry. Sandhya, sorry. You can do now.
Okay, uncle.
D and G are outside both A and B. is A. What is A complement? Okay, you got the set right. This is right. But the diagram is not right. Diagram is how, what is A complement? A, B. This is
A
A
must be
complement.
shaded,
This is
uncle.
universal. No, A must be shaded means it is A. A complement is everything that is not A. This is only A complement. Everything that is not A only is shaded. Okay, so D is here, G is here, B is here, C is here. That's why you are getting all of that. If you shade all that is in A, you will get A, I, okay, see, A, I, U, E, O. That only you'll get because you shaded this A, I, U, E, O. Then only that is only the set. This is A. This is not A complement. A complement is universal set minus A only is A complement. No, we saw that. Huh? Okay, but you are writing it correctly. A complement D, G, B, C is correct, but your diagram is wrong. Where is the confusion? Where is the confusion? Diagrammatically, this is the correct place.
Okay, uncle.
Are you able to understand?
Yes, uncle.
Yeah. So everything other than A is being taken now. A alone is left off. That is A complement. Okay. Let us. Okay. Now what you have to do? A complement is given. B complement from this diagram. B complement. Can you draw the Venn diagram, Arpana, and shade it and then write the thing? It will be nice. B complement is everything that is not B. Can you just draw the diagram? Hello, Arpana, are you there?
Yes, uncle.
Okay, I am drawing the diagram.
Okay, uncle.
Just shade in B complement.
Okay.
This is universal set. This is A. This is B. Shade B complement in this. No, you're doing
Yes.
the same thing. That is B. That is not B complement.
Oh, oh.
Use single strokes.
No, uncle.
Okay.
Using single scrolls, it's hard with
Coming.
my mouse, uncle.
Okay. Okay. Do whatever. As long as you get the answer. Very good. Okay, correct. So that is B complement. So now you write the elements of B complement. Don't erase
Over
it.
here, uncle.
Yeah. What are the
Elements of B complement, uncle.
No, you didn't shade this area. Where you didn't
Oh,
shade this.
sorry, uncle.
This area is not shaded. You shade it correctly. Yes, that is only B complement. Correct. B complement is everything that is not B. Everything that is not B is B complement. So from this A, I, U, D, G, that's all. E, O, B, C is inside B. You should not write it. Very simple. Okay. Now you somebody write, Sandhya write universal set. Universal set. Shading what? Very good. Correct. Yeah. Now you write that. Okay. Okay. Correct. Perfect. Correct. Perfect. That's right. Very good. Fantastic. Okay. Now you got the matter clearly. You guys have to rub this out, no? What you do? Can you rub out what you wrote?
No, uncle. I think you have the option of clearing all.
No, I died. I said clear canvas. It's not happening.
No, uncle. In the zoom option, uncle. In the zoom.
Trouble, uncle.
You should do it in the zoom options, uncle. Over there, you'll have the clear all.
Chat, share, app, more.
You have to go to annotate, uncle,
Yeah, annotate.
and click clear all drawings.
Okay. Okay. Example. 1.18. Okay. Now draw the Venn diagram and shade the region representing the following sets. Okay, A complement. Let me draw it for you because you did good work on the other one. Okay, I'll draw it for you. Draw the Venn diagram, share the region representing the following. Okay, this is universal set. This is A. Okay, what is A complement? Everything that is not A is A complement. Okay. This is A complement. Okay. You want to see that? Is doing A complement. Everything that is not A is A complement. Okay, let's put B also. A minus B complement. Let us see what that is. Let us draw the whole thing. This is A, this is B. Okay. A minus B. First one is A minus B. First step is A minus B. Okay, so you have to take this. This is the first step. This is A and you minus B from it. Okay. Then A minus B, the whole complement you have to take. So that is the second step. The complement of this thing. Okay. Complement of this thing will be Okay, this will be the complement. So A minus B the whole complement. Can we see what we are having? Let us see that. So this one. First step is this one. A minus B. Second step is A minus B complement. This one. Okay. First step is this one. Second step is this one. This one only matches what we have drawn here. All right. You understood? First is A minus B. So from A, you take off all that belongs to B. Okay. That means you take off all this. From A, you take off all this. Only remaining this one is there. After that, you do the complement of this. Then everything that is not this, everything that is not this is all of this. Okay. That's the one. Then one more thing we have to do. What else you have to do? So very important Venn diagrams. A union B complement. Okay. That is also very important. Two steps you have to do. You have to do it in two steps only. You can't do it in a single step. Okay. This is A, this is B. What is A union B? Everything here is A union B. It either belongs to A or belongs to B. This is A union B. Complement of A union B will be what then? Everything that is not here. So this will be the complement of A union B. Sorry. This is not there. This is okay. Yeah. So this will be the complement. So your shape will be like this. Okay. Yeah. So that also we have seen. Let us go and see if it is true here. A union B complement. Correct? It's coming correctly. So this whole thing is a white area. This one, the center. This whole thing is the white area. Okay, that becomes A union B. Okay, let us clear all drawings. We will do one first exercise or something, and you can do some homework. 1.3 you can do for homework. Okay. Friday, you come and sit in the class. We won't have class, but you sit at 5 o'clock to 6 o'clock, and you do the homework. Okay. All of exercise 1.3 you finish on Friday. We will do first sum. Using the given Venn diagram, write the elements of A. Okay, I will do this for you, and you can do the other one. Using the given Venn diagram. Okay. Here is a Venn diagram. This is union.
Uncle, shall I do the first one?
We don't have time now, already 8:10. That's why I'm going to do first one. You do all the remaining exercises, you only have to do. So 2, 10, 8, 4, 7, 9, 6, 3, and then we have 1 and 12. Okay. Anything else there? Nothing else is there. Find A. Okay, you tell me orally now. What is A? I'll write.
2, 10,
Hmm.
8, 4, 7.
Very good. That is A. Okay, Sandhya, you tell me what is B.
I've only said that, Uncle.
Oh, Arpana, okay. You tell me what is B.
It is 96347.
Okay, that is B. Then Sandhya, tell me what is A union B.
2, 10, 8, 4, 7, 9, 6, 3.
Very good. Okay. Arpana, you tell me what is A intersection B.
4, 7, uncle.
Very good.
Uncle, you have missed to write the 11, uncle, in the diagram.
Oh, 11, huh? Oh, that means B is having 11. Now A union B will also have 11. Okay. Okay. Very good. Thank you. Thank you for pointing out. Then A intersection B finished. Okay. A minus B. Whose turn now to say?
Sandhya, uncle.
Sanjay, tell me A minus B.
2, 10, 8.
2, 10, 8. Very good. Okay. Arpana's turn now. B minus A.
B minus A is 2, 10, 8, uncle.
No, that is A minus B.
Oh.
B minus A is everything that is in A, but not up. Everything must be in B, but it should not be in A.
9, 6, 11, 3.
Okay, very good. Now, whose turn? Sandhya's turn. A complement. Sandhya, what is A complement?
2, 10, 8, 1, 12.
A complement. What is A complement? A complement is defined as union minus A. Everything that is not in A is A complement. Tell me. You're still
9,
struggling to find
3, 1, 12.
9,
6, 3, 11, 1, 12.
1, 12. Very good. That is A complement. Okay. Arpana can tell me B complement. Everything that is not in B.
2, 10, 8, 12, 1.
Okay, very good. B complement. Union. Sandhya, union.
1, 12, 2, 10, 4, 7, 9, 6, 3,
2, 10,
11.
4, 7. Why you went from 2, 10 directly to 4, 7? Who will tell 8?
I've said 8, uncle.
You said 8, huh? Okay, 2, 7, 8. Okay, 2, 10, 8, 4, 7. Then?
9, 6, 3, 11.
Very good. Okay, union. You finished the first exercise. Very nice. Like that, you should do all the sums till 7 sum. Okay. Friday, you sit and work that out. That is the thing. Okay, guys. You want me to post this? I can post this. Okay, very good. Happy holidays. We should meet on Monday again. All right?
Yes, uncle.
Okay.
Bye, uncle.
Finish this and send me the, what do you call it?
We should finish
Snapshots.
1.3 fully, uncle.
One exercise we finished now. I mean, 2, 3, 4, 5, 6, 7. Only 6 sums.
Okay,
Yeah.
uncle.
You sit on Friday at 5 o'clock and finish how much ever you can. Okay. And
Okay,
then
uncle.
paste it on WhatsApp. Okay.
Bye,
Okay.
uncle.
Bye, guys. Happy holidays.
Bye. Happy holidays.